This is Algebra 2-3, and it's Unit 5, Simplifying Radicals. So this is the first day of the unit, and we're going to talk about how to break down radicals. So the square root of 64, y to the fourth. Now, think about what's the square root of 64. Everybody's going to say 8. The square root of y to the fourth is y squared. But let me show you why that works. You would take 64 and you'd break it down. You can use any number you want to start breaking it down into its factors. I usually start with 2 if it's an even number and go from there. So here are all the factors. Now, the number that's up here in the radical is called an index. And if there's no number here, you assume a 2, meaning we're taking a square root. We're finding pairs of 2 numbers that are the same. So I have 1, 2, 3 pairs. So this would be 2 times 2 times 2. That's where the 8 comes from. 2 times 2 is 4 times 2 is the 8. When you look at y to the fourth, you have 4 y's. Well, you're looking for groups of 2 because that's the index. 2 groups, you write y squared. There's no more radical because everything belongs in a group. Everything had a pair to go with. In problem number 2, we have the cubed root of negative 27. Let's ignore the negative for a second. Think about 27. You may have this memorized, but the cubed root of 27 is 3. This time the index is a 3, meaning we want 3 of a kind. So we're looking for 3 numbers that are the same. We found it. Now, if it's an odd index, meaning this number up here is odd. If you have an odd index, you just take the negative and you write it on the outside. You do that because negative 3 times negative 3 times negative 3 is what gives you the negative 27. And you can only do that with an odd index. Number 3. The cubed root of 125 a to the 6th. We're going to do the same thing. It's a cubed root. So we break this number down. We quickly see we have 3 5s. So we write a 5. We have 6 a's. We're looking for a group of 3. This 3 is the index. It's very important. We have 2 groups. We write a squared. There's no radical because everything belongs with a group of 3. I'd like for you to try number 4 on your own. And then I'm going to do number 5. So pause the video, try number 4. You should have gotten for number 4, 8, x to the 4th, y squared, z to the 6th. For number 5, we have this number 324. You may not know right away if it's a perfect square or not, so just put a number into it that you know can go into it. For instance, it's an even number. Try 2. You get 2 times 162. Do 2 again, and you get 81. 81, you know, is 9 times 9. So there are your groups. So we have a group of 2 and a group of 9. You can keep breaking the 9s down, but you don't have to. So we have 2s and 9s. This is going to be right here, outside my radical. We look at x to the 3rd. I'm looking for groups of 2 because of my index, and I have 1 group. You have 1 left over. We haven't had this yet. So you put your group out here, and then I'm going to rewrite the radical, and this is where you put what I call your leftovers. What didn't belong with any group? Well, you have 1 that doesn't belong with the group, so it's inside. You do the same thing with y to the 17th. You can write out 17 of them, or you can kind of think about, okay, you're looking for groups of 2. 2 goes into 17 8 times, so that's y to the 8th, but not perfectly. Y to the 8th implies that you get to y to the 16th. You need 1 more y, and it's left over. Feel free, like I said, you can totally write out all those y's if you want. 1, 2, 3, 4, 5, 6, 7, 8 groups with 1 left over. Z to the 9th. There are 4 groups there, 1 left over. Now, you would never leave your answer like this, as this 2 times 9. You would write 18, x, y to the 8th, z to the 4th, square root, x, y, z. Always make sure you multiply the numbers on the outside. Go ahead and pause the video and maybe try to work ahead of me on 6 and see how far you get. 432 is even again, so I would have taken out a 2. Then I divide by 2 again, I get 108, 2 times 54, 2 times 27, 3 and 9, 3, 3. We're looking for 3 of a kind. So I have 3 of a kind here and here. So that would be 2 times 3 outside my radical. I'm going to make my radical here. Very important. This index of 3 has to be here, means something totally different. So I put the 3 in my radical before I forget. M to the 3rd, there's 1 group, so we put M. N to the 5th, there's 1 group, 2 left over. P to the 7th, there's 2 groups, 1 left over. So then your final answer is 6mn p squared, the cubed root, n squared p. Now, number 7 is going to bring about a special rule. We're looking at the square root of x squared. And I'm pretty sure everybody's going to say x. How many groups are there? You would write it like this. You say 1 group, you write x. That's actually not true. It's the absolute value of x. And this is why it follows a pattern. First, you're going to look and see if you have an even index. When we look, the index is always sitting right here on our radical. It is even because it's number 2. And then there's a couple of things you check. Did you have an even exponent inside the radical? So x squared, 2 is even, so that's a check. And then you say, did it go to an odd exponent outside the radical? Look right here. This is x to the 1st. So yes, we had an even index, even exponent, and went to an odd. Then you have to use absolute value symbols. And we'll practice this. It doesn't happen often, but it does happen, so you have to be aware of it. Square root of 18, x to the 4th, y to the 5th, z to the 6th. Square root of 18. Break it down however you want. You have a pair of 3's. So 3 is on the outside, 2 is on the inside. X to the 4th, 2 groups are there. Y to the 5th, 2 groups, 1 left over. Z to the 6th, 3 groups. Now I'm going to ask about the absolute value. Did we have an even index? Yes. Did we have even exponents? Yes and yes. Y to the 5th is an odd exponent, so we don't even care about it. So we need to look at our x and our z. X went from even to even. That's fine. Z went from even to odd. That's where we want the absolute values, right around the z to the 3rd, and it just goes around the z. Number 9. Break 16 down. Be careful here. We're not taking the square root of 16. We're taking the cubed root. So we have a group of 2 on the outside, and we have a 2 left over that's going to go inside our radical. Be sure you put the 3 here. Here's a negative. Right here is a cube root. It is odd, so the negative just goes to the outside. X to the 7th. There are 2 groups, 1 left over. Y to the 5th. 1 group, 2 left over. Z squared. No groups. 2 z's are no groups of 3. You leave z on the inside of your radical. Now, let's check for absolute values. The first condition of an absolute value is an even index. Do we have an even index? No, so it stops. You don't go any further. We have an even index, we don't have to do anything. Or excuse me, we had an odd index, we don't have to do anything unless it's an even index. 3 is odd, we don't have absolute values. Square root of 50, x to the third, y to the 8th, z to the 9th. You can do this one in your head, hopefully. 50 breaks down. We have a pair of 5s on the outside, 2 left over. X to the third, 1 group, 1 left over. Y to the 8th, 4 groups, none left over. Z to the 9th, 4 groups, 1 left over. Then we look. Is it an even index? Yes. So we want to look at our even exponents. We have an even exponent. We got to keep going. Did my even exponent go to an even number or an odd number? Well, it went to even. That's okay. Odd is what we care about. So it was even, even, even. We're good. This whole thing is our final answer. We have one more. Square root of 36. I hope you know that is 6. X to the 6, we're taking the square root. So there are 3 groups. Y to the 10th, there are 5 groups. Z to the 7th, there are 3 groups, and a z is left over. Let's look for an absolute value. Is it an even index? Yes. Do we have even exponents? Yes. So we're going to look at our evens here. 6 went to an odd number, so you need absolute values there. 10 went to an odd. You need absolute values there. And you need to keep them separate. X needs an absolute value, Y needs an absolute value. We don't care about Z because Z was odd to begin with.